Hi all, welcome to sidza.com. Here in this lecture, we're going to discuss about the first law of thermodynamics. We all know that this first law of thermodynamics is a very famous law, and it's also, known as the law of conservation of energy. So it's related with the energy of the system of the universe. Okay, there are different ways, different methods of expressing, the first law of thermodynamics. But one of the very common method of expressing the first law is that we cannot create energy, we cannot destroy the energy. Only you can change one form of energy into another form. So energy of the universe that remains, the total energy of the universe that remains the constant. You cannot create or destroy the energy. Only we can change the one form of energy into another form. People tried many ways to develop a perpetual machine, a machine that could work without consuming energy. But human experience tells us that we have never been able to do so. We could not get any perpetual machine that could work without, consuming the energy. We cannot create any perpetual machine that can work of its own without consuming the energy. So you have to supply energy in any form. It can be the electrical energy, it can be the chemical energy. That energy will be converted into work. So you cannot get a perpetual machine that can work of its own because you cannot create the energy. We have a hot cup of tea at a very high temperature. We know after some time, if you put it on the table, it becomes cold. The temperature of this hot cup of tea decreases all of a sudden. But the question is, where does the energy go? The energy goes into the atmosphere, into the surroundings. So the energy lost by the cup of tea, it goes into the surroundings here. Because energy is not destroyed. If it disappears in one form, it appears simultaneously in another form, so that the total energy of the universe, it remains constant. Have you ever seen an aeroplane flying without consuming the energy? No, we have not. Why? Because for that also you need the energy, right? For the aeroplanes to fly, you need energy. So you are converting the fuel energy into the mechanical energy there. So basically, this first law of thermodynamics, it is a relationship between the internal energy, work, and the heat. In my previous video, I have discussed there that work and the heat. Work is not the energy. Heat is not the energy. Rather, these are the two methods, work and heat. These are the two methods or ways by which you can change the energy from system 1 to system 2. So there's a one complete video on the heat and the work, the two modes of energy transfer. The first law of thermodynamics actually gives us the relationship between the internal energy, work, and the heat. Let's say here, this is our system, a gaseous system, and it has some internal energy U1. Now, for example, if I heat the system here, I'm going to heat it, and Q is the heat that is supplied to the system. Now what will be the energy of the system? The energy of the system now, it will be U1, internal energy U1 plus Q. Q is the heat given to the system. So now the energy of the system will increase when I heat it. And the total energy will be its initial energy plus Q. And let's suppose here I'm going to work on the system. I'm going to apply some pressure on the system, and this piston moves down. This was the initial position of the piston, and now it goes down over here. And this will be the change in the volume there. Okay, this is the change in the volume. So actually I'm doing the work, right? So the work here which is being done on the system will be equal to P del V, pressure applied into the change in the volume. As I'm doing work on the system, so work, it will increase the energy of the system again, like we are giving heat, increase the energy. By doing work on the system, it will also increase the energy of the system. And now in the final situation, I can say the energy of the system will be U1 plus Q plus W. W is the work done on the system, so it will increase the energy of the system. Now this is the energy of the system, let's say in the final state U2. This is the internal energy of the system, which is initial internal energy, what it had, plus Q, how much heat supplied to the system, and work W on the system. Because work, it can increase the energy of the system, heat, it can also increase the energy of the system. So the total energy of the system in the final state will be U2, which is equal to U1 plus Q plus W. I can rearrange this equation like this, U2 minus U1 Q plus W. Or I can say the change in the internal energy, the change U2 minus U1, the change in the internal energy is equal to Q, how much is heat supplied to the system, plus W there, work done on the system. Right, this is the first law of thermodynamics. This is the equation we normally use, in the first law of thermodynamics. Change in internal energy is equal to Q, heat supplied to the system, and W is the work done on the system. We use the W, the positive, the negative sign only when the work is done by the system. That means when there is an expansion, the piston is moving up. And when the work is done on the system, we use the positive sign. So therefore, I can write down the equation here, the first law of thermodynamics, like delta U will be equal to Q plus W, means when work is done on the system, right? Here it is done on the system. But when the work is done by the system, so I can use this equation, delta U will be equal to Q minus W. It means that now the work is done by the system. Okay, work is done by the system, and in that case it means the piston is moving up, right? The work is done by the system, therefore the energy of the system will decrease. That's why the negative sign for the W. And we can also use the plus Q only when you are giving heat, and energy is given to the system when heat is absorbed by the system. And negative sign, negative Q, we can use when the heat is given out by the system. Energy is lost in the form of a heat by the system. We use there the negative Q. Hope you got the concept. Thanks for watching the video. Bye for now.